Okay, here we go. So before I even read the question, I can tell by the picture that's associated with it, or that goes with it, that we are dealing with quadrilaterals on a graph. Okay? So that gives me an idea of what I'm getting myself into. And now I want to read the question to find out more. On the coordinate grid, quadrilateral ABCD has vertices with integer coordinates. I want to pause right there. What does it mean to have integer coordinates? Okay, so we know that each coordinate has an x and a y. If we have integer coordinates, that means x and y are always going to be whole numbers. So let's say we got the coordinates 1, 2. These are integer coordinates, and that's where that point would be 1, 2. We're not going to get anything like 3.5, 4.5. Okay, only whole numbers. So nothing like this. 3.5, 4.5 would end me up right there, which doesn't look pretty. So integer coordinates means that x and y are both going to be integers or whole numbers. All right, let's continue with the question. Quadrilateral PQRS is congruent to quadrilateral ABCD. You see, this is important. With point R located at -6, -6, and point S located at -6, -9. Which of the following could be possible coordinates for point P? Okay, so what we're focusing on right now is the coordinate of point B. So that'll help me stay focused. By writing it down, I can stay focused throughout the problem as I'm working on it. Now, let's think about what they gave me. What I underlined in green. Quadrilateral PQRS. Let's write this down. PQRS is congruent to quadrilateral ABCD. Okay. And these are congruent to each other. All right, now, by lining them up like this, I can tell if these two quadrilaterals are congruent, then point P on one quadrilateral is going to match up with point A on the second quadrilateral, and Q with B, R with C, and S with P. So I'm given quadrilateral ABCD right here on the graph. What I want to do is I want to relabel ABCD P, Q, R, S, and put them with the matching vertices. All right, now I'm given R and S, and I'm asked to find the coordinates of point P. So if R and S are next to each other in the first quadrilateral, okay, they're consecutive vertices, and they're 3 units away, then they have to be 3 units away from each other here as well, which they are. So it looks like, just by looking at my first quadrilateral and comparing it to the part of the second quadrilateral that I have, it looks like all they did was rotate that quadrilateral 90 degrees. So they kind of put it on its side. So if that's on its side, I could try to guesstimate, mix between guess and estimate, where points P and Q would be. Okay, so if R and S are kind of like that, then point Q would be around here, and point P would be here. And that looks like I have a congruent quadrilateral. Let me just make sure. I'm going to count the bottom side first. So this is 1, 2, 3, 4, 5 units long. Just make sure. 1, 2, 3, 4, 5 units long. Awesome. Okay. And what I was counting was this. 1, 2, 3, 4, 5. I was counting the longer base of my second quadrilateral. All right. It looks like I graphed the second quadrilateral correctly. Now I just have to figure out which one of these is P and which one of these is Q. So if the quadrilateral is called PQRS, we got to make sure that it goes in order from P to Q to R to S around the quadrilateral. So if R and S are here, that means P has to be here, and Q is there. So it still goes in order as we go around. P, Q, R, S. Got it. Okay, so let's see if this coordinate right here matches up with one of my answers. So where is this coordinate? Let's find out. It is at negative. I start at the origin, and I run before I jump. So it's -1, -2, -3, and then -3, comma, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. That's where I got point P to be. Let's see if one of my answers matches up. Cha-ching. Got it. Yes. That is the best way to solve this kind of problem. Another thing you could do, if you don't like that method, the first few steps are basically the same thing. But what you want to do is label your various options. So let's say option A right here is -9, -5. -1, -2, -3, -4, -5, -9, all the way down to -5. Could that be P? Well, no, it can't, because that would mean Q is over here. And instead of being PQRS, this would be PQSR if you go around the figure. So that's not possible. Bad option. All right? Try B. -9, -6. -9 over here, -6. Well, no, there are no 90-degree angles in this first quadrilateral, so there shouldn't be any 90-degree angles in the second one, so that's not a good option right here. Here's our 90-degree angle, by the way. You didn't see that at first. And option C, -3, -9. -3, -9. Again, if you connect the sides, we have another 90-degree angle right here, but we don't have any 90-degree angles in this quadrilateral. So that is completely wrong. All right, so it's got to be option D, and we always test it out just to make sure. -3, -10 is right here, and that would be P. Q would have to be somewhere around here, which we already found. Boom, Q. P, Q, R, S. So you can connect the dots. All right, ladies and gents, great success. Raise your hand if you have any questions. Perfect. Everyone understands it. Great. Moving on.